This lesson covers the types of partition format we can use in Windows Server 2012 and also the types of disk, basic or dynamic. Once disks are available to a Windows Server operating system, the first task is to actually bring the disk online. So this can be done by right-clicking and selecting Online. The disk will be shown as not initialized. At this point, there is no partition table available for that disk. The next step is to actually initialize the disk, and we have the choice of selecting which disks that currently are not initialized to initialize, and also what their partition style should be. And we have a choice of master boot record or the GUID partition table. The MBR has actually been around since early 1980s and was used in the DOS days, and it has a number of limitations compared to modern computer systems. For example, the MBR only supports 4 primary partitions for each of our disks, and also only supports partitions up to 2 terabytes in size. The GUID partition table really replaces MBR and allows 128 partitions per drive, supporting up to 8 zettabytes in size. So if you require bigger than 2 terabytes, you're going to have to use the GPT format. Or if you want more partitions, then you're going to want to use GPT. The reality is you should always use GPT anyway on modern servers unless you require backwards compatibility for systems prior to Windows Server 2003. But if all your systems are Windows 2003 or above, you can just leverage the GPT format. Once the disks are initialized, by default they will be basic. So basic allows me to create partitions on the disk. The creation is performed by right-clicking. Now notice the naming is actually volume, but on the basic disk, we tend to think of it as traditional partition name. And I can create a volume and I can select the size I wish to create that volume to be. I also had options to create spanned volumes, striped volumes, mirrored volumes, and RAID 5. A spanned volume uses space over multiple disks, and the way this works is initially it writes all the content to one disk, and then it carries on writing data to the second disk and the third disk, etc. A striped volume actually works by alternating where it writes the data to. So one block is written to disk 1, the next block written to disk 2, the next block to disk 1, etc. A striped volume will actually give you a higher performance because if you think of traditional spindle disks, now I'm reading and writing to multiple platters, multiple spindles, which will give me higher performance. Notice, however, if I wish to use this format, I must convert the disk to dynamic. Dynamic disks are required for any of these RAID type storage levels. So while we're saying this is striping, this is known as RAID 0. It's not actually offering us any additional data protection, which is what we traditionally think of with these redundant arrays of inexpensive disks or RAID, but it's giving us some performance improvement. The challenge with RAID 0, however, is that if one of the disks fails in that stripe set, because the data is spread over all of the disks, if I lose one disk, I lose all of my data. So RAID 0 is typically used in a lab environment where you require very, very high performance for testing, but if you lose the data, there is some other mechanisms to restore it. RAID 1, or mirroring, utilizes 2 disks, and every piece of data that is written to one of the disks is also written to the other disk. This means if one disk fails, I have a complete copy of the data on another disk. The last option is RAID 5. RAID 5 is very similar to striping, although in addition to just writing the blocks of the data across all of the disks, it also writes a parity block for each of the stripes among all of the drives. This means that if one of the disks is lost, it can work out the missing data by combining the rest of the data available on the remaining disks and the value in the parity block, which means I can now survive a disk failure. If I'm comparing the RAID types, RAID 0 gives me access to all of the available space on my disks. I'm not losing any space for parity or mirroring, and I get great performance. However, that single disk loss means I lose all my data. RAID 1, I lose half of my available disk space because, for example, if I have these 2 disks used here, I'll only actually get 127 gigabytes of usable space, because every piece of data written has to be duplicated to the other disk. So I get good performance, but I'm losing half my storage. RAID 5 gives good read performance. It gives me protection from one disk failure, so I'm only losing, for example, a third of my storage, or in a 4 disk, a quarter of my storage. But my write performance can suffer, because for every write, it has to do calculations on what that parity data is. Now, in addition to these in-box RAID levels, there are other RAID available, for example, if you use external storage cards that offer those RAID capabilities. RAID 6 is a popular option. This is similar to the RAID 5, where there is a parity block, but instead of having one parity block, there are now 2 parity blocks. So I'm effectively losing 2 disks worth of storage in that RAID set. There is also RAID 0+1. So this effectively takes stripe sets and then mirrors those stripe sets. So it's a set of drives that are striped, and then those striped are mirrored to another set of disks. So this gives very, very good performance because I'm taking advantage of that striping capability, but I'm losing half of the available disk space because all data is duplicated. Another option is RAID 10 or RAID 1+0. So in RAID 10, what happens is several sets of drives are mirrored to a second set of drives. And then between all of those drives, striping is configured. This still means that I lose half the amount of available disk space, but I can tolerate a high level of failure, depending on which disks failed amongst the set. So I can survive a higher number of disk failures, providing both disks from each mirror don't concurrently fail. So I can have one disk fail from each of the separate mirror sets without experiencing any loss of data. Again, I'm losing half the amount of disk space, but I get high performance, and RAID 10 is typically used where I require the high performance, but also that very, very high availability, so protection from disk failure. For the inbox, I do have to use dynamic disk, so notice I can say convert to dynamic disk. If a disk already has volumes, I can convert to dynamic disk without any data loss. However, if I have volumes on a dynamic disk and wish to revert to basic, I will lose all my data. So it's very, very important you do back up all your data if you need to go from dynamic to basic. I can boot an operating system from a mirrored dynamic disk. This will actually give me protection if my boot or system disk fails, and then I could boot from the mirror. So I can say convert to dynamic disk, and I'm going to convert all of my data disks. I can then easily go and create a RAID 5 volume across those 3 data drives. I can give it a drive letter, leave the existing volume name, and you'll see the final amount of space I actually have available is going to be 2/3. I'm losing a third of my storage because of that parity data. And this can be seen in that RAID 5 dynamic volume. The capacity is 254 gigabytes, which is essentially 2 disks worth of available capacity. The reality is in your production servers, you typically won't use this software type of RAID, i.e. RAID that's being enabled by the operating system and using operating system resources and CPU cycles to calculate parity. Most production grade servers will have RAID capabilities built into the server that will give you the highest level of performance. And that's known as hardware RAID. So in production, you're going to want to utilize hardware RAID capabilities above this software RAID. But certainly make sure you are using some kind of data redundancy for your production data. And also, you're typically going to want to utilize GPT partition disks above MBR because of the larger volume sizes available and a greater number of volumes available on each disk.